Let's see, do we have a stream? Looks like we're live on YouTube. And we're live on Twitch again, yay. Sorry about the lack of Twitch streaming on the last stream. That was some technical difficulties. Apparently the failure mode, so I think that was caused by some half-complete Linux NVIDIA driver upgrade. And the failure mode there was that FFmpeg just failed to run because it couldn't open the CUDA driver. And then Nginx just seg-faulted a bunch because it couldn't run FFmpeg, I guess. I didn't fully debug what was going on there. Anyway, we're back. This will be kind of a brief, well, I don't know, maybe it won't be brief, but my plan for the stream is for it to be a fairly straightforward little stream doing some 3D printer maintenance. But just a quick look in on this this Winch bot that I've been working on. That's kind of the most assembled it's been so far. So the last piece I'm designing, well, I've got all the parts designed, I'm just debugging printability issues in the shell, basically, that translucent cover over the whole thing. So that black plastic piece on the left is a wall mount bracket that you can just attach to pretty much any wooden or otherwise kind of solid object with long screws. So here I just have it attached to the crate that's holding some unrelated project. I'm just using it as a heavy thing that I can drill into. And then the actual winch bot is made from those kind of brightly colored structural components. But then there's this translucent plastic shell that goes over the whole thing. And so it's pretty much all designed. I've just been slogging through the CAD process, finishing up the design, and finally just printing piles of parts. And the shell is the last piece that I'm just trying to get the first set of good prints from. So this is kind of truncated. You can see that it printed the side facing us and then kind of failed partway through. There's the printer working on the next attempt. The main change here was to make a lot of the geometry along those edges, the ones that build up and out, to make that a little bit thicker. Still, the overall strategy is to try to avoid printing with supports, so that angle that the case comes out at is really set by kind of the overhang that I'm willing to try to print. I'm hoping I didn't go a little overboard with that. It's a little bit hard to backtrack in the design at this point. I started out designing this in Fusion 360, and the design got complicated and messy enough that the parametric features stopped actually helping, and so I've been kind of escaping into Rhino to do the last little bit of cleanup, but it's mostly done at this point. Excuse me. Anyway, I just wanted to do kind of a short stream since I know I've been doing a bunch of CAD, and the next thing to do is honestly spending some time just getting to know particular Rust libraries. And so I thought a good thing to stream today might be some 3D printer maintenance that I needed to do anyway. This is my little printer. So I've got two printers. There's the big Type A machines in the closet that's printing the shell right now. And this is my Orion Delta from CME-CNC. And this has been a really great little machine. I've had this for just kind of cranking out little parts. It's not quite as accurate and not quite as, not quite as versatile as the big Type A on account of, the Bowden extruder means I can't use like flexible filaments. But on the bright side, it has this heated bed, and it's just a really reliable little machine. So this is actually the first kind of major maintenance that it's needed. Pardon me. Well, major is maybe overstating it. So I've basically got to rebuild the heating resistors in the hot end. So I can kind of show you the basics of this printer. It's also way too big to fit on my desk. It's a Delta printer, so naturally it's kind of tall. Oh, Bob says it looks really slick with the shell on. Oh, thanks. Yeah, I'm glad it's really nice seeing it come together. I'm hoping that the interface between the two shell halves ends up working out nicely, because that's one of those things that I can't really test until I have done a lot of printing, but yeah. So, you know, this printer is pretty nice. Really pretty much everything is in this base. So it's got 3 motors for each of these towers, another motor for the extruder over here. Then on the hot end, it has a heater, 2 fans, thermistor, and that's pretty much it. It's got this little wire whip that has the wires for the heater and the sensor, and of course the Bowden tube. But each of these, maybe we'll try going up a little bit. There we go. So each of these 3 towers, it kind of runs on these little skate wheels that fit into the aluminum extrusion. It's a really nice minimal design, but it's also good at being rigid and reliable. And so you can see that as these move around, the print head can move in 3 dimensions. So normally when it starts printing, you know, you'll select a file, it prints off of an SD card. And so it'll sit here, and first it's going to start preheating the print bed. I don't actually want it to do that, but you can at least watch it reset. So yeah, basically I don't really want to illustrate the problem right now because that involves trying to heat up the hot end, and since I'm about to disassemble it, I don't really want it hot. But the problem is the hot end is not getting hot. It kind of gets hot. But it doesn't actually reach the temperature it needs to reach. I think it maxes out at like 170 Celsius or so, which is not what you expect from a hot end. And so then I did a little bit of diagnosing, and the resistance of the heating elements in there is like 6 ohms, whereas it should be more like 4 ohms, I think. Or no, more like 3 ohms. Anyway, they actually have a pretty good guide on doing this replacement. The hot end has 2 heating resistors in parallel. I think they're each 6 ohms. And you just put them in, you crimp them. So they sell the replacement parts. You also need some of this thermally conductive silicone, which is some pretty cool stuff. Yeah, designed for high temperature gaskets. So yeah, I think it's basically RTV silicone, but loaded with copper particles, and then also formulated for high temperature somehow. So that seems pretty nice. And then to top it all off, they actually have a video on doing this repair, so we might refer to that. But let's take a look at this package. Oh yeah, Mikey suggests that the Delta printer mechanism might be fun for like the Tuco camera. Yeah, that could be neat. The Delta printer really relies on having rigid arms, which seems like, I don't know, you can certainly approximate that with cables. I mean, a lot of cable robots use a similar approach. With my particular robot, I've been trying to go the route of not needing it to be rigid, but, you know, that's also an experiment. Let's unplug this. Okay, so I got enough parts to do 2 of these repairs, since I figure I might need to do it again in the printer's lifetime. Oh, they sent me some stickers. That's great. Some CNC. It's been a good little printer. Cool. Let's put those over here. All right. So we have these kind of weird looking resistors. I don't know if I'm actually going to edit this video, but I might as well record it. Oh, maybe Mikey was talking about moving my cat around and not the camera. I don't know if Tuco would like that. Yeah, these look like some pretty big little ceramic things. Just trying to get the writing in focus there. .8 ohms, 2.1 watts. Or is that 2.1 or 21? That's got to be. So the reason you end up having to replace these heating resistors is that they're typically run way over their rated power, on the assumption that you're attaching them to a huge heatsink, but still they're running a lot hotter than they're really meant to, so they don't tend to last that long. Yeah, which other printer? I had another hot end that used heating resistors, and I had to replace them a couple times too. Newer designs tend to use heating cartridges, like little things that are actually designed to be heaters, but this is still an older design, and it seemed better to get the replacement parts than to completely replace the hot end, because otherwise this printer's been pretty good. Okay, so we might refer to the video if we need to, but I think basically the idea is you need to get access to the hot end, take it apart, take the resistors out. So the first step is actually to turn this whole thing upside down by inverting the towers, as they say. Just one at a time, pulling these to the bottom. Now there's better access to the hot end, kind of. All right, this arm sagging more than I was anticipating. And the camera arm kind of sags too. Okay. So then, I think you have to remove this zip tie temporarily. Without damaging anything it's attached to. Like that. How's everyone else's Tuesday? Does it actually feel like Tuesday? If it's not Tuesday, does it feel like Tuesday anyway? I'm mostly asking for people who are listening to this in the future, I guess, but about the not Tuesday thing. But maybe people listening right now, let's see, it's gotta be not Tuesday somewhere already, right? Yeah, it's already afternoon here. Oh, that's right. The next step, I think, is to take this, to loosen this washer, or loosen the nut, sorry. Apparently the wrench that I have within reach is the super overkill. Do I want to use this? That's the tube that the filament actually gets pushed through. Oh no, Bitcoin day. Okay, so what's the fan attached to? I don't know if the fan has to come out. Maybe I should refer to the instructions. I'm blanking on actually what the next step is. I think this nut gets loosened, but let's take a quick look at the video. Usually I would worry about plagiarizing someone else's video, but given that I'm basically advertising their printers here, then I don't think they'll mind. Also, I'm running it without audio because I really don't need the copyright bots. So we did that, and at 2x speed because I'm impatient. We did that. Okay, we did that. What's next? Yeah, let's do that next. We could use some of that. Let's do so much of that. Actually, let's do exactly the right amount of it. Okay, let's use a wrench that actually fits. Well, this one's still a little big, but I think it'll do. Alright, and then there's a spacer, which is another a laser cut piece of wood. Yeah, it's really amazing how well this printer works despite having laser cut wood pieces in it. That's right. So I think this shroud comes off next. It's a little plastic thing that holds another fan that just cools the heat sink on the extruder. It feels like it's stuck on something. Oh, there's actually some cat hair in the fan. Oh yeah, that just pulls off. Cool. That fan kind of needs some cleaning. Some lint in there. Alright, and then I think you can actually push this through. A couple of strands of wire are broken right there too, but I did actually measure the resistance at the crimps, so that's certainly not the only problem. I think the idea here is, I forget what you're supposed to do with this fan. Let's check the video again. Oh wait, what, how did that even just happen? I guess they just pulled it out of the, okay. I guess it just press fits into that 3D printed mount. Oh, yeah, cool. I see. And then we're still trying to get this through. It's kind of sticking on this piece. Oh, there we go. Okay. I think they recommended pushing the wires through, but I forget whether they wanted it all to go that way or the other way. What are we doing with the wires here? Okay, I already did that part. Yeah, got that. Pushing through the effector. Yeah. Oh, okay, and then you're doing it that way. That makes sense. Yeah, we can do that. Does this fan want to come out of here? I think it does. Oh, yeah. That's several good reasons. That piece is pretty clean, but the fan is covered in grossness. Take the compressed air to that maybe, very carefully. Something like that. Okay. Oh, Delta robots. Every maintenance operation includes a geometry puzzle. Oh yeah, this fan has some gook in it that maybe I could take care of with tweezers. There's like hair in this blower. There's probably also some maintenance I could do in the bottom side of the printer. There is a power supply fan. I guess I have had to do a little bit of work on the extruder stepper on this printer. It was having trouble overheating, and so I added a heatsink. And I did end up replacing the filament mount with my own solution, because in my experience it was kind of prone to jam, like the spool mount. Yeah, okay. Anyway, these fans are mostly fine. This is the part we're actually here to pick at. So, we have a heating coil and a thermistor. I think the next step is to start cutting wires and peeling off silicone, but let's double check what's going on in the video. Yeah, so we're taking out the heating wires and saving the thermistor carefully. And that Kapton tape was just to hold it mechanically. And so we're just kind of discarding all the stuff that's attached with silicone that we're replacing. Let's try that. I forget whether... I think this printer was... I got this thing fully assembled. I think it was offered as a kit, but I think I got the assembled one for some reason, but I don't remember entirely. I mean, I've taken apart and put back together a couple times, but I don't think I was the first one to put it together. And I don't think I haven't had to take it completely apart. I've just had to take apart certain parts of it. But I vaguely remember the hot end having some assembly required, because I remember it including a little, just like a little pot of this goopy silicone stuff. Or maybe I'm getting this confused with the MakerBot, because I know the MakerBot had a, like the original one, the original Thingomatic, it had a hot end with some assembly required because it was completely a kit. And it included a little bit of like ceramic paste of some sort for assembling the hot end. But I sure thought I remembered seeing a little, just like a little pot of this orange stuff. Anyway, so that's all separated. Cutting resistor. This is the thermistor. There we go. Maybe, is it a thermistor or a thermocouple? I was assuming it was a thermistor. Yeah, I think so. It's still covered with a little bit of silicone. Well, I think that'll bond fine to the silicone that I'm adding. I'm not going to fuss with it too much because I don't want to break it. Then I think I can pull these out. I think we can go back to the desk instead of hovering over the build platform. So this is a pretty basic 3D printer hot end, and it's like a, you know, like one of those illustrations you might find in a textbook on how 3D printers work. It's like you've got the heat, you've got the nozzle, you've got the heat break, and the cold end. It doesn't have that big of a heat sink, though. A lot of hot ends go much further to have heat sinking. They do have a fan blowing right across this top section, though. Oh, yeah. This resistor's seen better days. Oh, it's a wire wound resistor, and it looks like the ceramic has just deteriorated. We'll try measuring that to see if it's still got any ohmage. It might be open circuit. Ooh, this one doesn't feel good either. This one feels really crusty. I think this one's just going to disintegrate as I take it out too. Yeah, these resistors are not happy about the situation they've been put in. Let's grab the meter. That one is not conductive as far as I can tell. Is that just a problem with the leads? Maybe. I don't think it's just the leads. Oh, what was that? Oh no, that's because I was touching it. Yeah, okay, that one's open circuit. What about this one? That one is over its rating. So yeah, these things are definitely not doing much of a good job at heating anything. So, gonna make sure we have all the burned out remains of these resistors gone. Maybe a stick. Any silicone that's left in there, I would think would bond pretty well to the new silicone I'm adding. Apparently this also bonds pretty well to metal. It's not scraping off super easily. Goodness knows it's been cooked on there by enough hours of being hot. Okay, I think that's ready for new resistors. Let's consult the instructional video to see if that's indeed the correct next step. I wonder if are there resistors that's destroyed? You can't quite see. They don't look as destroyed as mine. Yeah, so that's the goop that I have. And so now we're just gooping. We're gooping, inserting the resistors, putting lots of goo all over the resistors. No part of the resistor free of goo. Even at 2x, this part's kind of slow. Yeah. Yeah, so this is coming up on the end because you have to let this cure for a while, and I was just trying to make sure I knew which steps happened after the curing, and so it looks like actually bending the leads and crimping them they recommend doing after you let this cure, but of course you have to insert the thermistor first. So I think that's what's doing. And so what I might do is try to set that up on top of the print surface here on some cardboard or something, and then I can just move the whole printer, put that aside, do other things. Speaking of other things, well, we have some cardboard. Anyway, you know, I think maybe one of those helping hands tools would do a pretty good job for this too, or even just a vise. I can tie up my vise for 24 hours. You can also see the insulating tube in there. Speaking of 3D printer basics. Ah, here it is. Alright, well, if I'm putting in the device, then forget what I said about putting it in the printer. I can just carry the device somewhere. Probably not necessary to protect this from the jaws even more, but I am. Oh, actually, this does need to be near the thermistor, doesn't it? Okay, let's try this. Can I get some more verticality? Okay. There's where the thermistor goes in. So the resistors are easy. I just need to make sure this is positioned so the thermistor can hang out in there stress-free while the silicone cures. Kind of like that. So I think what I'll do is just put a dab of silicone on the thermistor and in the hole, stick them in there, and then secure this with some Kapton tape while it cures. So let's open this stuff. I assume these little nozzles aren't especially reusable, but I guess I will try. I mean, I guess the strategy is to just plug up the end of this like you would with any other silicone caulking tube or something. That sure is coppery. Now I'm just making a mess. It's okay. There's a much larger mess to come. This particular piece of Kapton tape is temporary, but some other Kapton I'm sure will be necessary for this in the longer term. I want to make sure that has a decent amount of liquid around the outside too, just to keep the thing structural. Okay. Now the new resistors. It would be nice if there was a heating cartridge that was just the right size, but for now we've got these resistors because they match the piece of metal I've got on my hot end. I think I maybe should have used the wider hole on this. Okay, I feel like I'm just creating bald spots as I try to add more. This is fine. I don't know how easy it's going to be to get air bubbles out of this. Let's put this in from this side. Most of that does not stay on there. Just trying to make sure that whole area is wet with silicone. Like I don't just have dry spots in there. That's seeming better. I'm just going to make sure this resistor is actually kind of centered in there. Where is the actual end of this resistor? It is hard to see around all this equipment. I think that's about centered. Of course, now I've kind of disturbed the silicone at the edges, but anyway, that's probably about good for one resistor. Let's add another. When it's easier to move the entire printer than do anything else. Yeah, I'm sure next time I use this silicone, I'll have to cut the end of the tube off and make it a little bit wider, so that'll probably be easier. I mean, I don't know that this tube will still be intact by the next time my printer needs this repair, but I'll imagine I can find other things to use this on. It is kind of one of those things, though, that you kind of want them to sell in single-serving packets, like one ketchup packet full of thermally conductive silicone. So I got that. Oh, it's like a thread of plastic back there. Looked all wispy and smoke-like. Isn't what you want to see when you're working on heaters. Just touching up the side that you can't see and that I can barely see, and then I think it'll be about done. Can we rotate maybe? Well, that's badly lit, but we're almost done with this. All right. I think for this, I just get to leave it alone for a while. Isn't this fix exciting? Yeah, so I don't know what to do with this nozzle. I feel like if I leave this on, it'll just make it more likely for this entire tube to dry out, so... But I don't know if I'm going to be able to reuse the nozzle. I might just have to poke the silicone out through the middle. Alright, well I'm going to put this aside. Since we're streaming anyway, I might as well put the Winch bot up on the table briefly and we can take a look at its current status, but honestly I mostly just need to concentrate a little bit on code for that thing. I feel like I've just been going back and forth into CAD fixing bugs as they come up, or as the printer, has trouble with the model. But, there might still be a bit more of that to do if I have more printing problems. But aside from the process of actually just trying to get everything printed and fixing problems as they arise, I much more need code at this point than mechanical stuff. So I need some Rust code that acts as a server to let me just kind of read and write parameters on my robot so that I can have that graphed pretty easily. And I have kind of an architecture in mind, but I need to read a bunch of library source code to figure out how to implement it the way I imagine it should be implemented. Yeah, let's put this aside. This is so tall, I'm hitting the microphone, sorry. I still have not been able to figure out what YouTube means by this bad video settings warning. As far as I can tell, I'm giving them what they want. H.264. None of the individual settings seem wrong. The recording seems fine when I watch it. I'm not quite sure. I'm actually pretty happy with this wall mount bracket. It's reasonably easy to take off the wall and put on, and quite sturdy so far. So this is the networked robot thing. You can just add several of these and use them to build a kind of positioning system. I guess I'm not really sure what the scope of applicability here is. Like, who would want one of these besides me? It seems like it would be useful for cameras because it's not going to move a super heavy weight, but I'm aiming for smoothness and for it to be you know, not annoying to have around people and animals. So quiet and safe. And I was a little worried about how, well, unless you have super high ceilings like I've got here, you wouldn't be able to use this to get the camera especially close to the ceiling without having just a lot more force in these winches than the actual weight of the camera, just due to the geometry. But I think if you just also anchored another pulley in the center of the room to provide that extra lifting force near the ceiling, that might actually do the trick. But yeah, there's not really a whole lot more to show here. Just, you know, it's coming together. It's actually looking more like a solid object with, you know, some structure to it. And wall mount bracket attaches here and here. The electronics. Oh, Len says hi. Hi, Len. Oh, and they ask, where's Tuco? I think last I saw Tuco, he was upstairs, chilling out, probably on a sunspot somewhere. That is one of the limitations of this robot, is that there are certain places Tuco can go that you can't hang out with him, but I think that's probably good for everyone's mental health. So yeah, the next things I'm working on. So I've got that thing that I mentioned, basically writing Rust code that will also just involve reading a bunch of code to figure out how to use the libraries and which libraries to use, and just to get some structure so that I can actually interact with these bots. There's a little bit of firmware that I need to write to actually do the closed loop feedback control, but I think I kind of want the graphing and, you know, kind of parameter inputs and outputs to be a little easier to use before I go down that route. And then there's just time I can spend wiring this stuff up. I don't know how interesting that is to people. You know, I guess some people say, you know, just like stream anything, and I do to some extent. But then there's also cases where, you know, maybe I only really have the energy to stream, you know, X hours a day or a week or whatever. And so it would be useful to know like what people are most interested in, so I can try to allocate those, you know, the limited amount of energy I have to things that are actually interesting. You know, some things do take longer when I'm trying to get them on camera versus when I'm just trying to get them done. And I still don't know what's wrong with this YouTube thing. So it says bad video settings, please change the video's container format. The current container format is not correct for this configuration. And I have no idea what it thinks it's getting. Like, it should be FLV over RTMP with H.264. So I don't know. So yeah, I think this might be a fairly short stream then today, since I think the next stuff that I really need to get working on is stuff that is maybe not super interesting to stream. But we got to the point with the printer where I could just leave it alone and let that silicone cure, so isn't that exciting? Mikkel asks if YouTube wants MP4, not for live streaming. I mean, MP4 is not the container format they want for live streaming. They want FLV. And yeah, Bob says I don't know that it's even supported anything but RTMP. I'm with Bob. I have no idea what this error message is even talking about. Like, let me show you exactly what I'm seeing over here. Oh, really? Of course, as soon as I point the camera at it, oh, there it goes. So I guess it's going back and forth. So yeah, now it says the current container format is not correct for this configuration. It's like, what is that even talking about? So I don't know. I mean, I'll try doing some more debugging. I just haven't quite been sure what to do about it. I might see if I can get the Nginx server to stream elsewhere and then look at the logs for, you know, like a debug RTMP server, but I'm just confused about what it even thinks it's getting, so. But on the bright side, there's always T. Yeah, I'm with Len. Something is wrong. I know what it should be, but I'm not telling you. Oh, and then Bob says Wireshark is a good protocol decoder. Yeah, I should probably try that. I probably need to actually set up like a dummy streaming account so that I can be doing a stream and then also debugging it. I mean, unless you just want me to debug it like right now, which, could I do that? Well, how much info can I... Part of the problem is like debugging the streaming setup. I need to make sure I can do that without exposing any streaming keys or anything, but maybe I can drop the keyboard. Maybe I can just drop the keyboard. But no, maybe I can actually see if I can do that. Peter asks if dropping the keyboard fixed the issue. No, I think it's still having the same problem. Hello, wake up computer. Now I'm just trying to get my Mac to wake up. Well... That's right. It really gets me that macOS these days does not wake up from sleep if you just move the mouse. You actually have to click the mouse. Which I'm sure is great for people who are trying to conserve laptop power and who have cats, but when I'm trying to wake up the computer without causing any unintended actions, it's a little bit annoying. And Mikey is posting some developer documentation. How does that help me? Is there like a way I can get that status code easily unless I'm like in the bowels of some application? Oh yeah, Peter says that sometimes mice move on their own. Yeah, that's true. Sometimes that does happen. I'm just poking around looking for the right log files. Not seeing anything relevant from Nginx recently, which probably means What? Now I'm just losing keyboard connections. But yeah, I guess we could just Wireshark this. Do I have Wireshark on here? Squirt. Okay. Can I run this with like X11 forwarding or something? I'm trying to run this on the Linux box that's actually doing the transcode. Yeah, copper toothpaste, basically. this is probably safe. I've just been trying to like X quartz over there, and now I think this is, oh, here we go. Now it's giving me a terminal. I guess this keyboard shortcut wasn't working for me. Maybe that was a focus issue. No? Is my keyboard having problems? Huh. Yeah, and now I'm going to have the problem where I can't capture packets as non-super user, and Wireshark is not going to work with X forwarding. This, yeah. Why doesn't that work? Shouldn't sudo take care of the X permissions? And if I just, oh, well, that's got the same problem. Oh, is this a problem with the X forward? Oh, maybe. Ah, right. That's how you do this. That's right. -Y is the new -X. Yeah, great. So I think we just want to capture the RTMP traffic. This is going to get really messy if we're also capturing my SSH X forwarding stuff. Yeah, look at all that encrypted stuff. Actually, can I just RTMP? Is that enough? No, that's something different. That's routing table maintenance protocol. Okay, should I just do this by port? So there's actually going to be a bunch of streams happening. There's the stream coming in from the encoder machine, and then there's the stream going out to Twitch and the stream going out to YouTube. So yeah, I don't think I can safely do this on stream, because like once we find the URLs, that's going to give away my stream key, which is not something I'm keen on. So I'm going to have to debug this off stream sometime. But, oh well. I mean, unless there's something we could do, I can't think of anything useful we can do on stream to debug this. Alright, well, I think that might be it for it today. I'll try to avoid keeping this from dragging on, or try to, well, I've done that successfully. I'll try to avoid making it drag on too much longer. Thanks for joining me. Sorry there was no Tuco on the stream. He's been lounging around upstairs all day, but I'll have to stream sometime when he's actually around. Anyway, hope that was interesting. I'll see you next time. Happy hacking.